So it is module 4 class 4. Okay, and we will see the complete procedure to implement or design a Mealy state machine. Mealy state machine. Okay, now I am taking 4 states. Yesterday I had explained you this using only 2 states. Now we are making things complex. I am taking 4 states. So you can see how I am making 4 states ABCD. Now what I am trying to say is I have 2 inputs. I have 2 inputs which I will call it as X and Y. I have 2 input. I have 1 output which I will call it as Z. I have 4 states. I have 4 state which is ABCD. Okay. Now, yesterday I had given you the nomenclature. Now you will see how I am trying to show things here. Now, let me show that from C to D, the state changes if X is X dash Y. Means what? If X is equal to 0 and Y is equal to 1, then the state changes from C to D. Okay. C to D. Now, like this, there may be all the states will be joined. The state transition will be shown with these arrows only. Now, when I am showing the state change from A to B, and if I write only X, that means what? That means that state will change from A to B if X is equal to 1. Now, when I do not mention Y here, means Y is a don't care. That means if X is 1, X1, Y0, then also state will change. X1, Y1, then also state will change. So you make a note of this. The change of transition from A to B will happen if X is equal to 1 and Y is don't care. Means if Y is either 0 or 1, state will change if X is 1. The same way I am showing another case where state remains at A if X is 0. Let Y be anything. Y is don't care here also. So like this, I am completing the state diagram. B will remain in B when Y is 0. Now here X becomes don't care. Okay. In actual practical real time design, this will be the case. Okay. Now from C to D, I am showing XY dash. Means X should be 1, Y should be 0. B to C, I am showing only Y. Now X becomes don't care. Okay. You can mention for yourself in comment somewhere, whichever variable input is not seen, that is don't care. Now you see the complication here now. When I show X dash Y plus XY dash here, what does this mean now? D will remain at D in 2 conditions. Number 1, when X is 0 and Y is 1. Number 2, when X is 1, Y is 0. So in these 2 conditions, state D will remain at D only. Okay. Now last, I am showing you this, and now you will see so many arrows I made, but nowhere I mentioned Z, right? Nowhere I mentioned Z. In previous class, I showed you that in Mealy state machine notation, we put a slash here and then show Z. Now I will show you that condition. I am showing you now that from D to A transition happens if X dash Y dash, that means X and Y both are 0, 0. State changes from D to A and the output is Z dash. And the output is Z dash. Okay. And another condition. 2 conditions are there in this. Or if state changes from D to A in other condition when X and Y are 1 and 1, and in this case output is 1. Now can you see how much complexity has come here? One place I say that other input is don't care and transition is so easy. Another case I am saying that transition is so rigid or restricted that if X and Y is 0, 0, then transition happens making output as 0. If X and Y is 1 and 1, and then I say that transition will happen with Z equal to 1. Now, you may think what will happen to Z in all the other cases, in all these cases. So you can write two bullets here. Number one, if any input variable is not mentioned, if any input variable is not mentioned, then it is a don't care. Then it is a don't care. That is number one. Number two, what you have to understand here is that if Z is not mentioned, if Z is not mentioned, then what will happen? Then Z is considered as 0. So that means what? From D to A also, only one case Z is 1. For this case also Z is 0. And wherever Z is not mentioned, wherever Z is not mentioned, there it is a 0 only. Okay, there Z is 0 only. So this you will have to remember very well. Okay, now one more transition I will show you, that when from C to A also it can go. Mark that. From C to A also it can go when X and Y are 0 and 0. Okay, when X and Y are 0 and 0. So how will I mention? I have to mention like this: X dash, Y dash. Okay, X dash and Y dash. So this is how we make, this will be given in the question. Okay, or if you are doing a real time design, then the customer will give you certain condition and then you make this state diagram. So this becomes the first step of the designing. I hope I am clear. If there is anything, you please let me know. Okay, is there anything, any doubt, you please let me know. Okay, now the first step is writing state table. Okay, all of you are writing along with me, I guess. First step is writing state table. Now writing state table itself is quite complicated here. Okay, and you should understand things very carefully. So I am doing my next step of writing state table. Okay, now I will show you how to write, because it is very complicated in Mealy machine. Now you have to write your present state here. Okay, and there are four present state. There are four present state. So you will have your four present state listed here. Right now, in rest of the columns, what will happen? You know that there are two inputs, X and Y. So you also know when you have two inputs, there are four possibilities, right? If there are two inputs, there are four possibilities. So what are those possibilities? X, Y can be 0, 0, 0, 1, 1, 1 and 1, 0, right? So I will make those four possibilities here. So how will I write? I will show you here the possibility of X and Y, four possibilities, no? So I will have to write X, Y and output with respect to that, right? Next will be another possibility, second possibility, then my third possibility, and then my fourth possibility. Now let me show you how to make it. Okay, now the first possibility can be when X and Y is 0 and 0. Second possibility can be when X and Y is 0 and 1. And same way third is 1 and 1 and fourth is 1 and 0. These are the four possibilities which can happen. Now you have to closely observe your state diagram and make your state table. Okay, so what has to be done? You see here, I am in present state A. So present state A, I should see this. And I should see which all arrows are going out of it. Which all arrows are going out of it. So what you can see, number one arrow is going out of it from A to B. So A to B, and what is the condition? X is 1. So I will have to search place where x is 1. Now where x is 1? X is 1 for third column and fourth column. What about y? I told y is a don't care. I can also write here like this. Y is a don't care. Can you see I have shown dash here now? Y is a don't care. Y don't care means what? 1 1 as well as 1 0. Present state will change to B. Can you see how did I make this? If x and y is 1 and 1, state is changing from A to B. If the condition is 1 and 0, then also state is changing A to B. So that is how I have filled these two places in my state table. And what is the output? What should be Z? Tell me. What should I write for Z? Z is my output. Can you see here? Output is Z. What did I write here? If Z is not mentioned, then the Z is 0. So for both of this case, Z should be, what should be Z?
0, ma'am.
Correct. Z should be 0 only. So I have got the state change and also I have got the output. So both the things I filled. Now you will have to see that everything has to be filled. Now let us see. A remains at A when x is 0. A remains at A when x is 0 and y is again not mentioned. So x is 0 for first column and second column. Y is not mentioned means y is don't care. So it will be either 0 or 1. A will remain at A only. A will remain at A only and output is again 0 only. Okay. Output is again 0 only. Now this way you will be able to fill rest of it, right? Now let me check for B. B, one arrow is going from B to C. So that means y is equal to 1. So I will have to see a case when y is equal to 1. For all the cases when y is equal to 1, B changes to C. And which one is y equal to 1? My second column and third column. Y is 1. Can you see here? And because x is not mentioned, x is don't care. So for my second column and my third column, when y is equal to 1, B is transition to C and Z again remains 0. Okay. Now let me check the other part. When this arrow B remains at B when y is 0. So now I can see my first column y is 0 and my last column also y is 0. So B will remain at B. B will remain at B if y is 0. Also Z is 0. Z is 0. Same way you people can do it. Now you should answer me. Now you should answer me. You can see C is most complicated. Three arrows are going out of C, right? So let us see one by one. C to B. Which column I should write this? C to B. Which column I should write?
1 and 0, ma'am.
1 and 0 means it is last column, right? So C to B, last column I have written. And Z is again 0 only. Now C to B I wrote. Now C to A, where I should write which column?
0 to 0. 0, 0.
0, 0. That is first column. That is C to A. Next, two arrows over. Third arrow. Third arrow says X dash Y. X dash Y. C to D. C to D. Now, C to D, when it will happen? When it is 0 and 1. Right? C to D, it will happen when it is 0 and 1. Of course, it is 0. Z is 0. Now, can you see? I am not able to get what should I do for x equal to 1 and 1. Why I am not able to do? Because this state diagram is not complete. And this part I have missed. All of you update your diagram also. C remains at C when x and y is like this. C remains at C. Okay. So, you have to fill your third column also. You have to fill your third column also. Okay. Now, so let us write our third column where C remains at C and Z is 0. I hope you people will be able to do for D now. D is also not that very simple. D is also complicated. We have to see two conditions. D remains at D. That is x dash y and xy dash. X dash y means what? 0 and 1, right? 0, 1. X dash y is 0, 1. Actually speaking, we can write here also these dashes. It will be easy for us to check, right? Anyway, okay. So x dash y is 0, 1. So where is 0, 1? Here is 0, 1. So D remains at D. Output is 0, of course. Other one is xy dash. Xy dash means 1, 0. 1, 0 means here you get, and this also D remains at D and you get a 0. Next, I have to see from D to A. D to A, 1 and 1. So D to A, and here my Z is 1, right? Now, x dash y dash is 0, 0. So D to A again, but Z is 0. Now you can see my state table is complete. My state table is complete. So now I will complete this state table. Now you all know digital logic. You also know that it is not possible to mention variable in your, it is not possible to mention variable in digital system. You can mention only numbers, that too binary numbers. So next is called as transition table. We will make transition table out of the state table now. That is your next step. Now, when you see that you have 4 variable or you have 4 states, then how many variable will be required? How many state variable will be required to make this state? Tell me. How many state variable will be required to make 4 states? If you remember yesterday's class, I had mentioned about this. If n, if number of states are something, then 2 to the power n will give you number of states. So my number of states is 4 now. So what should be n? N should be 2, right? So I need 4 states. So what we will do now is, to begin with our transition table, we will have to give names to this state. Okay. So I will give names to this state. Then only we can do the transition table. So state A will be 0 and 0. State B, I will take it as 0 and 1. It is my choice. I can take whatever. Now I am taking state C as 1 and 1. I could have taken 1 and 0 also, no problem. And but simply I am taking like this. D is 1 and 0. Now what will we do in state transition table? All these ABCDs will be replaced by this 0, 0, 0, 1, 1, 1 and 1, 0. Okay. So next we will be making the state transition table. Okay. All of you are clear till now? Can I go to the state transition table? Tell me fast. Can I go to the state transition table?
Yes.
Okay, so I'm going to the next page. You people will have to draw the state transition table based upon what I have told. Okay, so state transition table. State transition table is nothing but same thing what you did in the previous page. Only the change is we will be calling, instead of state, we will be calling as number. Okay, number. So present state, and your x, y are all same, 0, 0, z, then x dash y, then z, then x, y, then z, and x, y dash, and then z. Same thing. Now, instead of writing A, B, C, D, I will write it as F, A, F, B. Okay? F, A, F, B. All of you have to write it as F, A, F, B because I am changing the things for I am changing these variable a to 0 0. So this 0 0 will be what? This 0 0 will be FA and FB now. Okay. Both of it is called as, this will be called as F. I'm not able to write here. It will be called as FAFB. Okay. FA and FB like this. So that will be written. That will be written here. The same thing. So this A will be written as 0 0. Wherever A is there, there you are supposed to write 0 0. So A was 0 0, B was 0 1, C was 1 1, and D was 0 0, right? And your Z is 0 for all the cases. Z is 0 for all the cases, as we have seen in the previous page, except for one case. So let me copy it quickly. Let me copy it quickly. In the third column, last case only, your Z was 0. Rest all the cases, Z was 0 for all the cases. Now, A to A it was going now. So this is 0. I am simply replacing A by 0 0. So wherever A has come, I am writing 0 0. Okay. So it is simple replacement. I am doing that. You have to check that I am doing the replacement properly, because you have both the table in front of you. Right? Last one, it was going to which state? It was going all the time? It was going to B state. B is nothing but 0 1. Any doubt in this? B is 0 1. And last one was D, that is why it is 1 0. So this is called as your state transition table, where we are converting the state variable to state function, FAFB. Okay. Okay. Now, next step is writing excitation table. Now, when we write excitation table, it will be based upon the type of flip-flop. Now, you have already done design of counter using various flip-flop. So you all know the most easy change is with D flip-flop, right? Now, what I will do is, I will do the most easy one for your first class of state machine. I will say that I want to use D flip-flop for implementation, for state machine implementation. What I am doing today using D flip-flop, you people have to do it using TJKSR. The way you did counter, the same way you will have to do this also. Now, because it is a D flip-flop, the next table, or what do we call as excitation table. Excitation table will be simple to implement if I am using D flip-flop. Okay. So next step, again we will make one more table. Okay. Excitation table, what should come? You remember what do you mean by excitation table? Excitation table says, if I want to change this 0 0, if I want to change this 0 0, if I want to change this state from 0 0 to 0 0, what should be the input of my D flip-flop? You remember, this is what we did in counter also. So if I want to change present state from this to this, under this condition, what should be my input of the flip-flop? That is called as excitation table. So now I am writing my FAFB again. Okay. You will see that this time table is simply being repeated. Okay, why table is being repeated? Can somebody tell me? For D flip-flop, if I say input of D flip-flop, DA and DB, if I take like this, what should be the excitation input? You all know D flip-flop say that Q is equal to D. This is my Q. This is my next state. This is my Q. And D flip-flop says that Q is equal to D. So Q will be equal to D. So your FA, FB will become equal to DA and DB. So I have to simply copy my previous table. But this copying of previous table is happening only because I am using D flip-flop. If you do not use D flip-flop and if you use JK flip-flop or T flip-flop, it will not be like this. I hope you understand. Can you tell me why it will not be like this if I am not using D flip-flop? Can somebody answer? I am waiting for the answer. In D flip-flop, I am simply copying the output FA, FB, or we can say QA, QB, same as D. But how the change will happen for other flip-flops? How the change will happen for other flip-flops? FA and FB are output. DA and DB are input. That is why we call it as excitation table. Excitation table means what excitation input has to be given to DA and DB to get the output as FA and FB. So what I am drawing now is excitation table. Okay. Now, of course, again I have to write my Z input. Z not input, Z is an output. Z output. So all the cases Z was 0, 0 only. Only one case Z was 1, rest all was 0, 0. I hope this is clear. Now, most important work, writing decimal notation for each excitation variable and output. What is the excitation variable? I have number 1 excitation variable, which is a DA. Next excitation variable, I have DB. And output, I have to write the decimal notation, minterm input of all these three. Also, you should know that DA, DB and Z, this is function of what all? This is function of, can somebody tell me? This is function of what all things? Of course, you should also understand this is my current state and this is my next state. So I should always write plus here. You remember we used to write Q and Q plus. So whatever is in right hand side, it is your next state. Next state. The way in counter you used to have, no? So this is your next state and this is your present state. So what is your next, this next state depends upon, next state depends upon your present state and as well as this list of input, right? And for that we made this excitation table, which will make my next state as FA plus and FB plus. For that I need to give excitation input. Now I am making equation of this excitation input. So excitation input is DA and DB. Also, I need to know the equation of Z, that is output. So, DA, DB and Z is function of what all things? It is function of present state and present state and present input, right? This is what we knew of Mealy machine. It is present state and present input. So what is present state? Present state is defined by FA and FB, and present input is decided by X and Y. So in the same order, in the MSB to LSB order, FA being MSB and Y being LSB, we need to write this. We need to write this. Now, this will be in minterm form now. Now, most difficult, you have to understand how I am writing this minterm now. You know that function is FA, FB and XY. So, it is in the order of FA, FB, X and Y. This is the order. Okay. Now, we have to see DA. All of you see carefully. I have to see in DA column where and all I have 1. Where and all I have 1. So I can see in first column it is not there only. Second column it is 1. 3 ones are there. I have to read it. And what is the order of reading? Order of reading is like this only. FA, FB, X, Y. So what is it? It is 0, 1, 0, 1. Right? So what do you get from 0, 1, 0, 1? 0, 1, 0, 1 is nothing but a 5. Do you understand this? 0, 1, 0, 1 is 5. Next we come to this. What is it? It is 1, 1, 0, 1. Or we can go row wise also. We can go row wise also. 0, 1, 0, 1 was 5. Now let us see this. What is it? 0, 1, 1, 1. 0, 1, double 1. And what is 0, 1, double 1? Somebody tell me. What is 0, 1, double 1? 0, 1, double 1 is nothing but 0, triple 1. What is 0, triple 1?
7.
Right. 0, triple 1 is a 7. So my next number is 7. Now this is not there. Now I can come to next numbers. So 1101. What is 1101? 1101. 1101 is a 13. Yeah,
13.
right. So I have an answer I have listed here. Now let us see. 7 you got. Now you had seen 1101 is 13 I got here. Next 1111 I got. So I got a 15 here. This one is what? 1001. So it is a 9 here. And next, what did I had? I had 1 here also. So that is what? 1010. So that is a 10. So DA, I have got 1, 2, 3, 4, 5, 6 ones. So I have listed my 6 minterms here. Right? Same way we will have to do for DB also. Now DB. DB, how many ones are there? So many ones are there. So I have to list out. I have to list out in the same fashion. So DB is 1 here. It means what? 0, 1, 0, 0, 1, 0 means what? A 1. This is what? 0, 1, 0, 1. So it's a 5. What is all these 3? 00, 11. So 3. 0, 1, 1. So it is a 7. And like this. So I am listing the answer here. It is 2, 3, 4, 5, 6, 7, 40 and 15. So you can see how many ones I had. 1, 2, 3, 4, 5, 6, 7, 8. So I should have my 8 minterms here based upon these ones, right? And what about Z? What is Z? Which minterm is there for Z? Only 1 here. And what is it? It is a 1011. And what is Z? 1011 means it's a 11, right? I got my DA, DB, Z in the form of function of minterms. In the form of function of minterm. Next, what we are supposed to do? Anybody can guess? Next, what we are supposed to do? In 5 minutes, your answer will be there in front of you, the final answer. Little K map. Very good. Right. You are supposed to make a K map now. So I have to make a K map for DA now. And the K map for DA means we are supposed to, how many cells K map will come? How many cells K map will come? Yes, answer please.
16, ma'am.
Yes, you will have a 16 cell K map. So let us make that. Cell K map for DA. So I will not take much time for this because you people know how to make a 16 cell K map. So any one of you can do it quickly also and tell me what will be the equation of DA and what is the function. MSB is FA, FB, LSBs are X and Y, right? And we have to give the values. So it is 0, 1, 2, 3. We have to complete the mapping of my K map. All of you should do all these along with me. Okay. Next, we have to write our K map. So we have 5, 7, 13, 15, then 9 and 10, right? We had this. Now what next we have to do? We have to do grouping. When you see grouping, you can see one group here. Next, you can see one group here. Last, there is no group, so this will be alone, right? So what is my DA? DA is, all are waiting for me only to write. FBY, FA, 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 X dash Y. Next is FA, last one, this alone one is there na, for this one. It is FA, FB bar, X, Y bar. This is your DA. In the same fashion, you will get your DB. You can make a K map of DB on your own. I am giving you the answer. Okay, you can do it on your own. DB, the same way you will make one more K map for your DB. You can do that on your own, and I am giving you the answer for DB because I have the answer with me. FA dash FB plus FA dash X plus FBX. Okay, for Z, do you want to make K map for Z? What was minterm of Z? Minterm of Z was 11, remember? So without making K map, I can simply write FA, FB dash, X and Y, right? That is minterm 11, no need to make K map, right? So DA and DB, of course, you will have to make a K map. For Z, you don't have to make the K map. Now the final thing is your final diagram. And how do you make your state machine? You have seen in counters also. What do you do? In counter also, we make our flip-flop. So here we will have our flip-flop. Because this is D flip-flop, we will have only one input for the flip-flop. Your DA and DB are the input and FA and FB are the output, right? You have your FA dash also, you have your FB dash also. Anyway, we are not much bothered, but of course you have this available with you. Now you got this equation of DA, right? You got this equation of DA. So you are supposed to give this input circuit diagram. So DA is equal to OR operation of three things. So just to make your circuit clear, I will simply show here that for this one, FA dash X and Y. Now you have to understand, I need to show the two inputs also. So I will show two inputs like this. These are my inputs. Okay. These are my inputs. These are my inputs. Okay. And I should make available X dash and Y dash. My X dash and Y dash are available to me like this. Okay. Now the first AND gate input is FA X dash Y. So what I will show? I will show my FA, I will show like this. Of course, I can show the connection also like this, that FA is being connected like this. I can show this also. Okay. Then I have other one is FB dash. So next input is FB dash. And third input is FA, FB dash and XY dash. So I can show that I am connecting X from here and I am connecting Y from here. Do you understand this? So I am showing what is coming out of this FA, FB dash, X and Y dash. And this along with other two inputs of your FBY, FBY and another one which is FA X dash Y. All these will come in one in OR gate, and that will become your DA. So rest connection you can show in a neat way. Okay. Next connection you can show in a neat way. I wanted FBY, right? I wanted FBY. So I will take Y and I will take FB also. So FB I can bring from the feedback. This FB I can bring, or otherwise I can simply show here that this is my FB. Okay. Now FA X dash Y. FA X dash Y. You know that X dash is available very near to you and FA is also available very near to you. From here I can take, or I can simply mention here because it may become very cumbersome to show. I am showing my X dash and Y, and FA I am showing like this only. This is my FA. So like same way you have to make for your DB also. Okay. You have to make for your DB also. For DB also you have three terms. So you will get three AND gates, and those three AND gate will give like this for your OR gate input, and you will get for this. And your input values you can show here, which is your FA dash FB, second one is FA dash X, third one is FBX. So like this you can show. Now what about your Z? Z is also there, no? Z is also there, right? So for Z, what is the equation? Z is FA, FB dash, and so you have to show all that. Okay. So FA, right? Then FB dash, right? Next you have your X and Y. X and Y. Now one more thing what we can show is already your X and Y is available here. X and Y is available here. So what we can show is either we can show connection from this XY, or we can also show that I am again putting a NOT gate and making it as a pure XY, and all these four are going in one AND gate and you get your output Z. Do you understand this? So this is your state machine for the question we started. Okay, this is the state machine for the question we started. We need to find this logic diagram for your input DA and DB and also for your Z. So this is called this state machine. If you connect this circuit, it will behave and it will implement this state diagram. It will implement this state diagram. So you can see it is just a 3-page procedure, not that very difficult. I hope you all have understood this. Any doubts you can ask me.